All right, guys, I don't know. I'm guessing you can hear me. I can't see you or hear you. So we're going to get started here. So there's a few of you signed in. So I shared my screen so that you can kind of see what's going on my end here. So I just wanted to give you guys a chance to kind of walk you through what's going on this week and kind of how I'm going to organize looking forward. So let me just get myself organized here first. Okay. So this week, what you guys are going to be doing. So what I did was I set up on a document here, kind of what is happening each day during the week. So last week I kind of had everything due, at the end of the week, but I decided to kind of break it up into days. So this is, like I said, the first video class, and I'm going to try to do these a couple times a week, depending on what it is we're doing. So today we're going to talk about dihybrid crosses, which a lot of you have already kind of started the assignments for. There's another new assignment in there that's due tonight, and then there's a CK12 practice as well. You can get both of those on Google Classroom, and those are both due tonight by midnight. All right. Tomorrow, we're not going to have any video class or anything like that, but you do want to start kind of reviewing all of your notes. And there's another assignment in there as well from Khan Academy, and there's some optional practice. This I'm not grading, but it has some additional practice on dihybrid crosses if you feel like you need it. And you can do that if you want. The solutions are in there. The quiz I'll talk about more on Wednesday. So Wednesday will just be kind of a review question and answer section. I'll open up your mics and things like that, and you'll have a chance to ask any questions you might have for that quiz, and that quiz will be on everything that we've been talking about with genetics, and I'll post kind of like a review list of review topics for that. And the quiz will be 20 multiple choice questions on Google Forms, so look out for that on Wednesday. All right. Later on the week, Thursday, Friday, I am pretty much just kind of blowing up what I was going to do. So I'm putting together a unit on pathogens, disease, public health, immunology, viruses, because I feel like that's a very important thing for us to be talking about now. So that's going to be what we're talking about starting on Thursday, and I'm putting that together, and I'll talk about that more as it gets closer. Okay, so that'll be what we're starting, and I'll have that ready to go for Thursday. Okay, let me see if I can actually hang on a second. I want to. Okay, I got a chat here. Oh, that's okay. So I can kind of text everybody to this, and then I'm going to see if I can turn off some of your mics at certain times. So I've never really used this Zoom, so just kind of bear with me here. All right. So the first thing I want to do is just a little warm-up question. So take a second. If you have a piece of paper, you can do this. Some of you might not need a piece of paper, but as a man with type AB blood is married to a woman with type O blood, they have 2 natural children and 1 adopted child. So the 3 children are Jane, Jordan, and Marlon. Jane has type A blood, Jordan has type B blood, and Marlon has type O blood. Which child was adopted, and how do you know? So I'll give you a second to think about that. And if anybody thinks they know, I think you can kind of raise your hand in here. I think you can do that. If I see anybody raise their hand, I'll call on you. I see everybody. All right, well, I don't really know how to do that, so I'll just go through it. All right, so man with type AB blood. So we know when we're looking at blood type, A and B are codominant, right? Meaning that both of them are expressed at the same time. And O is your recessive blood type, right? So O is recessive. So in this case, we have someone with the man is type AB, so we have our genotypes for blood type written like that. So the big capital I represents blood, right? So whenever you see that, that's what we're talking about. So we put a little a, little b to represent the person with type AB. And then we're crossing that with someone with type O, and we use two little i's to represent O, and because it's recessive. So if you couldn't kind of figure this out in your head, which you might have been able to, but just for the sake of completion here, we'll roll out our Punnett square, and we'll get our potential offspring here. And what do we get from this? Well, all of these, so we've got A and then a little I, so it masks this little I. So we've got 50% chance of having type A blood, and then 50% chance of type B blood. Okay, so which child was adopted, right? It had to have been Marlon because there's 0% chance and there's no II at all in the Punnett square. All right, any questions on that? I'm not sure how I would even answer your questions. All right, so let's talk about dihybrid crosses. So you have this PowerPoint all in a Google Slides on Classroom. So you can, some of you have been writing the notes. I told you kind of do that. Just keep your notebook consistent. You can write the notes down, or you can just kind of have them to look at. But I just wanted to take some time to talk about this. So dihybrid crosses show the results of a cross between organisms for two traits inherited together. All right. So one of the things that Gregor Mendel found was that sometimes we have traits where there's a linkage, right? So dihybrid crosses represent a linkage between two traits. So they're kind of stuck together, the loci on the alleles of the homologous chromosomes. Okay, and to show the results of a dihybrid cross, we need to use a different type of Punnett square. So we use a 16 square dihybrid Punnett square. So how do we solve a dihybrid Punnett square problem? So the first thing that you're going to have to do is you're going to have to, continuing kind of what we did when solving the easy genetics problems, is we create a key to our alleles. So whatever it is that we're looking to solve, you want to address what's dominant, you want to address what's recessive, and you want to list those out, because it becomes kind of difficult when we're looking at all these different traits. Okay, list out what the parental genotypes are and show your cross. Okay, the next step here, to kind of show you all the possible combinations you get from that cross, you have to FOIL. Okay, so this is the same thing that you do in math with foiling monomials, right? So FOIL stands for first, outside, inside, last, and I'll show you that example in a second. So you're going to take each of the the genotypes of the parents, and you're going to essentially get all the combinations from those alleles by foiling them and putting them on the sides of your Punnett square. Right? Next step is to draw and fill in your 16 square Punnett square by dragging and dropping all of the alleles to their proper box. And the last steps are to analyze, and the probabilities, again, are out of 16 and not out of 4. Okay? So this general kind of way of solving is the easiest way to attack these types of problems. Okay, so let's do one problem together, and then I'll have you guys do one on your own. So again, if you have a piece of paper in front of you, it'll make it kind of easier, but if not, just kind of listen. So in peas, genes code for seed shape and seed color. Round shape is dominant to wrinkled, and yellow is dominant to green. Okay, show a dihybrid Punnett square for the cross between two heterozygous round yellow pea plants. What percentage of the offspring will be round yellow? So again, the first thing we want to do is we want to list our parental genotypes. Okay, so we're crossing two heterozygous round yellow parents. So we know that round is dominant, so we're going to use a big R for round. And wrinkled is recessive, so we're going to use a little r for wrinkled. Yellow is dominant to green, so big Y for yellow, little y for green. Show a dihybrid for the cross between two heterozygous parents. So that means that the parents are both heterozygous for both traits. So we've got a round yellow parent crossed with another round yellow parent. So how do we put these genotypes on the Punnett square? Well, we have to FOIL each of the parents. So in this case, they're both going to be the same, but we'll go through just for completion what they are. So when you're looking at first, all right, you look at the first two alleles in the genotype. So first here are big R, big Y. Outside, this R, this little y. Okay. Inside, little r, big Y. Last, little r, little y. Okay, so that's for that one parent. We've put all the different combinations of how these could be inherited together. So in the past, people have asked me, oh, okay, so why did you put the little letter first, right? These are not genotypes over here, they're combinations, right? So just keep that straight. They do the same thing for the second parent. In this case, they are exactly the same. Okay, so again, first, outside, inside, and last. And here it's pretty easy. You just have to drag and drop everything into the square. So we drag and keep the alleles together. So big R, big Y, big Y. Okay, big R, big Y, little y. Okay. Big R, little r, big Y, big Y. Okay, so you can fill this in if you're kind of working along with me. So pretty easy, like I said. It's just sometimes people get confused with the foiling part. Just make sure you foil one parent and then foil the second one. So one parent here, one parent there. And these can be a little bit tedious, but there is a predictable pattern for all of them that we'll talk about. You can also have Punnett squares that are even larger than this, but it becomes very cumbersome to do that. And generally, they're not really done that way. When you're looking at 3 traits linked together or 4 traits linked together, this is kind of the biggest Punnett square that you'll see. Okay, so the question says, what percentage of the offspring will be round and yellow, right? So we have to find all our big R's and all our big Y's. Okay, so these are all round and yellow. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 16. Right? So generally, when you're seeing these dihybrid Punnett squares and it's 2 heterozygous together, it's always going to be the same ratio. So let's say you get a problem and you're looking at it on your quiz, and it's the same thing. It's 2 heterozygous. It's always going to be a 9 to 3 to 3 to 1 phenotypic ratio, right? So in this case, it's 9 of them that are round yellow, 3 that are round green, 3 that are wrinkled yellow, and 1 that is wrinkled green. Okay? So why don't you guys take a few minutes to try this next one on your own about polydactylism, and then in a few minutes we'll talk about it. And this is also in the PowerPoint that you guys have as well. All right, let's take a look at this. If you're not done, just kind of check your work here and make sure. Okay, so it says in humans, polydactylism, so is having an extra finger on each hand, is actually a dominant trait. So typical five-finger arrangement is recessive, and polydactylism is going to be dominant. So let's assign this an allele. I'm going to use F for finger just because I don't like using P because P is hard to kind of tell the difference between uppercase and lowercase. So F, we're going to say is polydactyl, and or big F, and then little f is normal. Okay. Tongue rolling, we've seen this one a bunch of times already, is dominant to not being able to roll your tongue. So we'll give that an R. So R for can roll, little r for cannot roll. Okay. A man who is homozygous for five fingers and who cannot roll their tongue has children with a woman who is heterozygous for polydactylism and tongue rolling. Draw upon a square that represents the cross. And what's the probability the couple produce a polydactyl baby who cannot roll their tongue? Right. So man is homozygous for five fingers. So he's normal. So that means he has to be this, right? Little f, little f. And he cannot roll his tongue. So we also know his genotype there. He marries a woman who's got six fingers. So she's heterozygous, which means she's going to carry a normal allele covered up by the polydactyl allele, and she can roll her tongue. Now, usually, if someone is polydactyl, they'll cut off the little extra finger when they're a baby, and it's not a big deal. Usually, people don't have the extra finger for their life, but I guess you could if you wanted to. But anyway, so let's take a look, and we'll put the genotypes. We'll FOIL. So again, first, outside, inside, last, really easy for this one. So they're all the same. They're all big F, little r. For the mom, we have to FOIL. So first, outside, inside, last. Okay. And then we just very simply drag and drop our alleles into it. And these are going to be all the same, all across. Okay, so you guys see that they would be all the same. Same thing here. And they're all the same in this case. Same thing. And here we have, oops, homozygous, recessive all the way across. So the question says, what's the probability the couple is a polydactyl baby who cannot roll their tongue? So in each of these cases, right, here we've got a polydactyl baby that can roll. Okay, here's the probability of a polydactyl baby cannot roll. Okay, so that's what they're asking for. Here we've got normal and can roll. And here we've got normal and cannot roll. Okay, so for all of these, it's 4 out of 16, which is 5%. Okay, so that would be that. So like I said, these can seem a little bit cumbersome, but you'll see that there's predictable patterns when we look at these. All right. So the homework that you guys are going to do is on Google Classroom. So the thing that I just kind of added is the dihybrid reading and review questions. So what I'm doing now is I'm going to, for these reading assignments, this isn't the right class. For these reading assignments that I put, each of you will get a copy of it. Okay, so if I just open one up and show it to you, and you just have to read, and then there's some questions at the bottom, and you answer the questions at the bottom using your own words and a color of your choice. And then when you're done, you just hit submit. Okay, so don't forget to hit submit or turn in, whatever it says. And then the second thing that you're doing tonight is the CK12 hybrid practice, which is also in Google Classroom. That's been assigned. Both of those are due tonight, and I think you should be good with hybrids at that point. I think that's everything I want to say. So the biggest change this week going forward is that we will be looking kind of at a day-to-day sort of thing, not a weekly sort of thing, just because I was getting a whole lot of emails last night, or not really a whole lot, but some emails last night, and most people paced pretty well, but some people need to kind of have due dates a little bit more consistent. All right. Does anybody have any questions about anything that I talked about? You can type them into the group chat there, or you can message me directly. I'm going to see if I can actually, I'm going to unmute everybody for a second. So, oh gosh.
Hello.
Oh, hey guys. So going forward, if you're comfortable with the video, I can make that kind of your option to turn on the webcam. It is kind of weird just looking at your names. I literally feel like I'm talking to nobody. But I guess this is a little better than when I was just recording myself. But how's the online learning going overall?
Horrible.
Yeah.
Terrible.
Could be better, could be worse.
I think this class is like the most organized out of all of my classes right now.
Oh, yeah.
Yeah, I agree.
You know what? It's because I've taken online classes before and I've taught online classes before. I did my whole master's online, so I kind of know how to organize this. But from what I'm seeing from my colleagues on like Facebook and stuff like that, is they're all like freaking out and they're given like ridiculous expectations. I'm like, you can't treat it like a regular class. Like this is not, we're not in school. So
Yeah, I
I
have a
don't know.
class where they just dumped a whole bunch of work with really sporadic due dates.
yeah. So I don't know. The best advice I could give you is just to like hang in there. I feel like there's a very, very good chance that we won't be back to school for a while. So
How long do you think it's gonna be?
I think we're not going to go back. I'm optimistic that we'll be back by May.
Oh God.
That's good.
Do this for another month.
I know.
Last Monday, I talked to Mr. Tweed, and he was like, "Ooh, I don't even know if we're gonna even come back."
I don't want to think like that
Mr.
because
Tweed
it's
is
just,
losing his mind. He really is.
I bet. But I mean, if the gym were open, I'd be fine. The fact that the gym is closed is just making me go crazy. But all right. Does anybody have any other questions about anything for the class? So I'm going to start this immune system unit on Thursday, and I think that's going to be really good for all of us. I'm putting together a good kind of information about viruses and things that I think will really help you figure out what's going on and educate yourself with all this stuff. Okay. All right. So if there's no more questions, send me an email. If not, I'll see you guys. I think the next video class I have is for Wednesday, and it'll be more just kind of like a review of everything for genetics for the quiz, and that'll be that. All right. So you're welcome,
Thank
guys.
you.
Be safe. I'll see y'all. Signing off.
Bye.
Bye, guys.
Bye.
Bye.
But
How do I do this?